Tomorrow, we're going to Mars. The decision has been made, and now we have to start planning. Greetings, everyone. Welcome and thank you for joining us today. I hope you're having a good time during this virtual convention of the Mars Society. I'm Yasmin Trabelsi, a Tunisian college student, and I'm part of the Postcards from Mars project. We're a team of 8 people from the Education and Outreach program of the Mars Society, and we've been working on this project for the past 3 months. We're an international team with different backgrounds and various cultures. We've put our efforts to create a guidebook on how to go to Mars. It is an illustrated book that deals with the main steps of planning a trip to Mars. In fact, why wait for the decision to be made? Let's make it ourselves. Be the change you want to see in the world, that's what they always say. We are going to Mars, and this book, combining fact and fiction, is a simulation of how to get prepared for such an odyssey. Think of going to Mars like any other holiday destination. On that basis, for the sake of the project, we follow the same steps anyone usually takes to plan any trip. Of course, the first thing you do is decide on when to go. This decision takes in consideration various factors and technicalities. It is thus of the utmost importance to make the right decision. To know when we are going to Mars, we have to define a strategic launch window. Generally speaking, launch windows are defined according to the distance between the 2 planets and to the current propulsion technologies. Due to the fact that every 2 years, the distance between Mars and Earth is minimized, scientists predict that an opposition-class mission will last less than a year in Earth time with a short duration stay on Mars. According to SpaceX, the use of high-energy trajectories will allow Starship to transport in less than 4 months 100 people to Mars with the liberty of choosing the duration of their stay. Although these types of missions are perceived safer since they don't require a long period on Mars, they are not considered to be plausible due to the advanced propulsion technologies they require. On the other hand, a conjunction-class mission is a long-duration mission, during which the first leg of the trip alone can last more than 6 months. On Martian's surface, the crew would be spending around 500 days before journeying back to Earth. Although these missions use reasonable propulsion technologies, they last longer than opposition-class missions. The ultimate goal would be combining short-duration trips and the use of the least amount of propellant. As the duration of conjunction missions varies according to the launch window, this might be possible if the spacecraft is launched as an optimized launch window. 2033 would be an optimal launch window, for example, as it allows a relatively shorter time in transit compared to other conjunction-class missions, a reasonable amount of propellant, and average duration stay, and therefore fewer risks for the crew members. Now that we've known where we are going, the next step is deciding where to land. Which region exactly should we direct our focus towards in our research? Multiple factors are in play here. I'll leave it to my teammates Khalda Sharek and young Neil Bandari to present their amazing job and their analysis of the situation. We know now when we are going and where exactly we are heading. Obviously, question now is, how will we get there? In Postcards from Mars, we have considered and carefully studied more than one option. Contrary to unmanned missions, the question here isn't how to go there, but rather how to get there safely. The book discusses multiple obstacles that cloud the safety of the mission. 2 of the main issues are zero-G and radiation. Both have disastrous effects on the human body. Dr. Michael DiMario, with his brilliant expertise, will explain the solutions to these problems as well as the different technological craft alternatives that can safely transport a crew of 3 people to Mars and back to Earth. Now that we've secured the technicalities of the trip, we still aren't prepared yet. Astronauts still have to be selected at the end of a series of medical exams, and they have also to go through a hard training program, both physical and mental. Abhishek Soni will enlighten us later on the subject. Now that our astronauts are ready for the trip, one crucial element has yet to be explored before engaging in our voyage. Sadly, Airbnbs are not a thing up there. Maybe in the future, who knows? So for now, where will our astronauts settle down for 500 days? The habitat described in Postcards from Mars is inspired by Mars Society's MDRS. The habitat has to protect the astronauts from the harsh Martian weather, and it has to ensure heat, electricity, oxygenation. Berke Yildirim wrote this section of the book, but unfortunately, he couldn't be present with us right now. We have discussed all the main elements that compose our trip to Mars. However, nothing ever goes perfectly as expected. How good would that be? Unplanned events are very likely to occur, potentially endangering the lives of crew members. They can be related to internal factors like medical emergencies, engine troubles, or external factors like meteors, radiation, or solar flares. Due to the absence of air and gravity, the potent radiation, and the meteors, space is a hostile environment for humankind. Current technologies don't allow short trip, therefore the risks are great and can be intensified due to the unpredictable events such as technical issues or health emergencies. In fact, medical emergencies are the holy grail of unpredicted issues that can occur. In space, amidst total isolation, astronauts in case of such emergencies are utterly alone. It is therefore necessary to have and apply medical guidelines. Weightlessness is a real threat to the human body. Space adaptation syndrome is the major illness. Seeing as it has no medical treatment, astronauts have to adapt, and its various tiresome symptoms principally related to space motion sickness. Despite all that, the human body adapts itself to the new environment. Astronauts have to maintain a healthy and strict lifestyle to keep their bodies in check. Spine, bone, and heart strength is crucial, as bone density and muscle mass are gravely diminished. Also, spending around 3 years in space requires a lot of discipline and consistency regarding the maintenance of the spacecraft and the habitat. One small glitch can endanger the crew and change the course of the whole mission. It is therefore crucial that the astronauts have a daily schedule dedicated to the maintenance of the different systems. The systems composing the spacecraft and the habitat are carefully designed to have subsystems that are independent of each other. As a result, if a failure occurs or a part is broken, the system will still be able to deliver minimum results. In other words, all the vital systems can properly operate even if some of their parts need fixing. However, some systems cannot be conceived with such a design, so the engineers make sure that all the important parts composing the system have a long lifespan. A caution and warning system is a must in the spacecraft and in the habitat. It has to rapidly recover to default mode and stay operational during the power failures and other anomalies. It alerts the astronauts and assists them during the emergency protocol. And finally, abort systems and safe haven are an example of emergency protocols. They enable to salvage the crew and bring it back to safety at any stage of the mission. Unfortunately, they also mark the end of the mission. Postcards from Mars also includes various illustrations made by our very talented artists Priscilla Thomas and Jeff Pullinger. These postcards are supposedly sent by actual astronauts stationed on Mars. They give the book a more human approach, conveying letters from astronauts to their family members and friends. This was Postcards from Mars in a nutshell, the fruit of countless efforts by a diverse team whose members are scattered all around the globe. As we are in the editing phase, any inquiries to participate to the project are welcomed and expected at this email address. Thank you everyone for your attention. I will now direct the spotlight at my colleagues and friends. Enjoy the rest of the presentation and don't hesitate to ask questions. Thank you.
This is Michael DeMario, CEO of Astrum Systems. This portion of Postcards from Mars presents Earth-Mars transit scenarios. In the Postcards from Mars, we've included a section on the Earth to Mars transit spacecraft and their associated characteristics, including artificial gravity, cognitive communications, artificial intelligence, and radiation mitigation. 3 Mars transit vehicle scenarios are presented here as a SpaceX Starship Victoria low Earth orbit assembled modular vehicle, and a Dragon Orion transit vehicle with a habitat in combination with a Mars ascent vehicle and an Earth return vehicle that are previously sent to Mars. The SpaceX Starship is a methane and liquid oxygen propellant 390-foot spacecraft with reusable first and second stages. The Mars Starship portion is the 160-foot second stage. It's capable of lifting 150 metric tons to LEO and of landing with a 50 metric ton payload. On this mission, it will employ a crew of 3 to enable more payload and 3,500 kilograms of consumables that can support a 3-person crew up to 3 years. The Starship is refueled in LEO by a heavy lift Falcon. Another fully fueled heavy lift Falcon, acting as a traveling fuel depot, upon leaving LEO, will join the Starship and connect via a tether. The traveling fuel depot of methane and LOX is a safety measure to lower the risk of not being able to produce methane and LOX in situ on Mars. It also serves as a counter mass for artificial gravity. This ensemble will spin about a central axis to create an artificial gravity environment. Upon reaching Mars orbit, the Starship will untether from its countermass and deorbit to land on Mars, leaving the fuel depot stage in Mars orbit. The 256-long Victoria Mars 3-person crew transit vehicle is assembled in LEO, comprised of a Dragon Orion crew capsule. The Victoria assemblage is architected to be an interplanetary transport system, whereby it may serve multiple and varied space missions to the Moon, asteroids, and Mars. The Dragon Orion crew capsule serves dual purpose as an Earth ascent vehicle joining the already assembled modular spacecraft in LEO, and serves as an Earth descent vehicle upon return to Earth. The Mars ascent descent vehicle, a single-stage methane and LOX propelled 100 metric ton spacecraft, has been previously sent to Mars, whereby it docks with the arriving Victoria at a 500-kilometer orbit about Mars, the 3-person crew to transport to the Mars surface, while Victoria remains in Mars orbit. The Mars Direct Modified is a 3-event logistical plan Dragon Orion capsule supported by a Falcon Heavy Earth launch that can deliver 53 tons to LEO and 17.5 tons to Mars. In Event 1, a Dragon Orion Earth return vehicle with a methane and LOX propellant stage is parked in Mars orbit with an uninflated space habitat. In Event 2, a Mars ascent vehicle, a single-stage rocket delivering 11 tons of payload, is sent to Mars. In Event 3, the Falcon Heavy launched 3-person crewed Dragon Orion and a space habitat to be employed once in LEO. The 8,600 kilogram 2-deck inflatable space habitat is 8.7 meters long by 6.3 meters in diameter with a volume of 180 cubic meters, and it supports a crew of 3. The Starship artificial gravity system will create a gravity environment of at least Mars equivalent of 38% to Earth's equivalent gravity. To generate the Earth's artificial gravity, the Starship spins about the center of mass, tethered to a refueling stage. The Starship is tethered nose to nose by a 170-meter non-conducting tether, continuously rotating the entire complex at 2 revolutions per minute. The fuel tanker will remain in orbit about Mars to be retethered for artificial gravity on the return Earth transit. The artificial gravity system on Victoria is comprised of 2 living 400 cubic meter habitat modules spinning about the spacecraft axes, positioned in an axial or parallel orientation. The spin rate is 3.5 revolutions per minute, providing approximately half of Earth's gravity to maintain crew muscle mass while remaining in a comfort zone, preventing dizziness or other uncomfortable sensations due to rapid movement and Coriolis effects. To reduce bone loss, this spin rate will slow the amount of bone loss with supplemented exercise and pharmaceutical remedies. The Mars Direct artificial gravity system with the Dragon Orion and inflatable habitat spins tethered to an expired trans-Mars injection stage by non-conducting tethered tethered, continuously rotating the entire complex at 2 revolutions per minute. The expired stage and inflatable habitat will remain in orbit about Mars to be retethered for artificial gravity on their return to Earth. As collection of space data increases, the complexity of the spacecraft increases. The delay of Earth communications due to greater distance, and in this case for 2033, an average of 4 minutes one way, or 10 minutes minimum, to receive a knowledgeable support reply to a problem, requires increased autonomy of the crew from Earth-based support. To facilitate communications due to expected delays due to distance and solar event interference, cognitive radio, the infusion of artificial intelligence into space communication networks, is used and integrated into the communication systems of the spacecraft. The cognitive radio system is data-driven and uses non-deterministic methods and decision-based algorithms to improve communications autonomy, optimizing the communication bandwidth, the frequency, data routing, antenna pointing, and asset management. Space radiation primarily consists of galactic cosmic radiation and solar particle events consisting of protons and heavier particles. To put radiation dosage into perspective, 1 millisievert of space radiation is approximately equivalent to receiving 1 abdominal X-ray. An average CT scan is 10 millisieverts. A 180-day transit to Mars is approximately unshielded 325 millisieverts, and 500 days of Mars is about 325 millisieverts unshielded. For a 35-year-old male and a 35-year-old female crew member, the implied medical radiation limit is 2.5 sieverts for the male and 1.75 sieverts respectively. Ionizing radiation is mitigated by materials with high amounts of hydrogen. The space industry uses aluminum alloys for primary structures, augmented with polyethylene or water for radiation shielding. Water is very heavy and would require a thickness of 30 centimeters or about 42 metric tons to provide sufficient radiation shielding. By 2033, we are hoping that the Mars missions, as well as crew member clothing, have new promising technology of hydrogenated boron nitride nanotubes. This technology is made of carbon, boron, and nitrogen, with hydrogen interspersed throughout the empty spaces between the nanotubes. BNNT has a high strength to weight ratio, high temperature resistance to over 950 degrees centigrade, whereby aluminum melts at 660 degrees centigrade. These nanotubes are about 1,000th of the thickness of a human hair and provides a nanoscale structural reinforcement in a variety of materials. BNNT is an excellent absorber of ionizing radiation and secondary particles, making hydrogenated BNNTs an ideal shielding material. It has good structural properties for load bearing and high temperature stability. And this concludes the Earth to Mars Transit Vehicle presentation. Thank you.
Good morning, everyone. I'm Abhishek Soni, a mechanical and aerospace engineer, and I worked on the training section for Postcard from Mars. I'll also be going over the habitat section, which was done by Burke, but since he's unable to present it today. So training, that's one of the most essential things for going to an interplanetary mission. Starting off, training and medical check. Of course, a training needs a medical check if you are in full strength, if you are physically and mentally capable to go from what we call our home now to what we might have a home in the future as. Now, I'll be going over quickly through the personal and social aspects of the training, the technical training, the group training, and finally, the medical checkups. As you can see, one of the fellow astronauts, which maybe in future could be one of you, would be doing like some weightlifting or bench presses, or maybe some dumbbells. So going on to the details for the personal and social training aspects, I just classified it into 3 broad categories of crew selection training, crew diversity, and human factors. Now, as we know, selecting a crew is the most essential step and the first and foremost step in heading towards a Mars mission. Different people, how they interact with each other, what they bring from their background, that's a key issue. Psychological aspect of any mission will define the success of a mission. Microscopic challenges to macroscopic challenges, that whole transfer from micro to macro, can just render mission a failure. The second aspect is crew diversity. Now, we come from different backgrounds: North America, South America, Asia, Africa. We all have our own cultures, but when we together come as not individuals, but as humans to meet one mission, we add on our strengths and leave behind our weaknesses. And third, and most important, is the human factors, because dynamical behavioral analysis is something which is key for the success of a mission. And from any trip, whether it's to ISS or whether it's just to your friend's place, the behavior, how you interact with the people around, can have a varied impact. Next is the technical training aspects, and this is kind of one of the most essential ones, since if you have to operate a spacecraft, or how do you survive in a microgravity environment, or when the G values are changed? How do you gauge that someone from their face basically recognize that they are under some kind of stress? Or how are they interacting? Are they having mood swings? Or they are trying to be isolated? Or they're not interacting, or they are being aggressive? So these four detailed boxes, which the G-force simulation, microgravity operation, Neuralink, and facial analysis, spacewalk, and operations. G-forces, as you know, it's basically either you are at a centrifuge where you would be subjected to different G-forces, as the anti-G suits currently can handle around 8 to 9 Gs. So maybe why not do testing for beyond that and subject to what is the durability point. Then is macrogravity operation. Now, as Mars is not a zero gravity environment, so how you survive in a microgravity environment would be essential. Neuralink and facial analysis. Well, I guess everyone would have seen how pigs with the Neuralink chip work, and getting data from them helps to study their behavior and predict. Similarly, maybe if we can implement or implant chips in an astronaut's head, and then they can transfer data, or maybe we can predict what is their behavior, which neurons are spiking, so that we can predict if they are feeling isolated, feeling lonely, or maybe just under some stressful environment, or maybe they are just hyperactive. That would help in improving any mission compromises. And facial analysis, so that would basically be like personal digital assistants that can understand the cognitive behavior and help and mitigate any concerns, and ultimately spacewalk and any other operational scenarios, which of course the astronauts will be preparing, as even they have been doing for missions to ISS and beyond. The third aspect is group training, and this is, I believe, one of the mission success and drivers, because if you can't come together as a team, you will die as individuals. Team training and fusion, that's the most important aspect. And as we know, that nuclear fusion generates more energy as compared to fission. And similarly, team fusion and bonding would generate more positive energy as compared to just being individuals working on their individual tasks. A past NASA report, and also studies at MDRS, which is the Mars Desert Research Station, FMARS, which is basically the Flashline Arctic Mars Desert Research Station. There have been simulations for 2 weeks there, which give a lot of data in terms of how the teams have performed as a group, or when there were incoherent behavior, their missions have been a failure. Similarly, the psychology aspect combined with the training and medical aspects also contributes in the fusion and team training. Next is the medical checkup, which is, I feel, not the least, but the most important one, because if you're not physically and mentally capable enough to perform a task, or handle stresses or maybe have certain scenarios which are like a medical emergency, then on a 4-month or 5-month duration to Mars, it could be catastrophic, not just for you, but you could basically be catastrophic for the other people in a scenario where the spacecraft has to be turned or there has to be some kind of a maneuver to perform. But if you're having people dealing with the ill person, then this could be a mission compromise. Now, just going over the key aspects of my colleague Burke's part, which is for Mars habitat. As you can see, this image is from the MDR's habitat floor. So this could be an architecture which we might be using for future Martian colonies. And the most essential aspects are landing, of course, living there for a longer period of time. Leaving, when you leave Mars, what do you leave behind? And how do you live a sustaining civilization? And how do you establish it for future mankind? Through Postcard from Mars, we have tried to collect multiple aspects and diversity related scenarios from how, when, where, why, training, and just some collection of beautiful pictures created by our fellow colleagues, which you will hear in the upcoming presentation part. I hope you all are having a great conference, and we look forward to hearing back about any questions for Postcard from Mars and for any contributions. Thank you.
Hi, everyone. I want to share how I found myself providing illustrations for this book. My education includes California Institute of the Arts, Art Techniques and Appreciation through Sailor Academy, and a number of other courses. And as a former aerospace technician and a fine artist, I seek to capture the human touch in the setting of our reach for the stars. My love for space has taken me to NASA rocket launches, open houses, and NASA media events, and my art has been featured in magazines, books, and newspapers. Recently, though, I've turned my attention to ways I could support our reach for the stars, and Mars Society was an obvious way to do this. I want to share why I'm so excited about the art in our book, Postcards from Mars, and why I feel its unique approach in using postcard illustrations will help reach new audiences, and why it'll inspire their support for space programs and space exploration in general. When I ask people what inspires them about space exploration, responses most often come back to images. And most often, of course, you guessed it, the image of Earthrise that I used in the first slide. This response highlights the importance of images that speak to people's hearts and minds, that speak in a way that resonates with their reality. Our book, Postcards from Mars, uses both the language of art and the personal humanizing element of a postcard headed back to loved ones. In 1968's Earthrise expanded the scope of many people's sphere of appreciation and even their sphere of awe. Images can do that, augmenting communication in words with communication in the visual. I'd like to imagine this augmenting or coupling, when used effectively, as another dimension reaching people. And this is where the unique approach in Postcards from Mars comes in. The concept that the team leader came up with for sharing illustrations and technical content in a way of humanizing it was just great. Each chapter contains illustrations of concepts and items explained within, but in the context of Postcards Home, from the perspective of the explorers who are experiencing them. And these illustrations can help reach new audiences, people who feel the science of engineering becoming a spacefaring civilization to them, people who don't resonate, who don't view exploring and settling new worlds as relevant to their experience of life. Postcard illustrations using both art and personal words can help bridge that gap. So you see, Postcards from Mars uses art with personal, humanizing messages loved ones receive from explorers to take that Earthrise vision, flip it around, that looking back at Earth from our moon, make it looking out to new vistas in space together as humanity. I've included in these slides some samples of the illustrations used in the book, and I can convert these to a PDF if desired for after the session. But let's take a moment and picture in our minds a world of social strife, rioting, protests, a sense that we're losing a grip on a civil state, and many fighting for a new, more just balance. It sounds like 2020 how? Well, it was also the case in the late 1960s. But imagine within people the desire that we would rise above all this, the desire to act based on a bigger picture, the greater good for all. With all the strife going on in the 1960s, they closed with the remarkable achievements of the Apollo space program. And 1968's Apollo 8 mission was the first time we sent humans beyond Earth's gravity well. Astronauts sent us Christmas greetings from the moon, but they also gave us this image, one that everyone remembers. With all that was happening here on Earth, we also finally had this image of hope. Thousands of telegrams and letters came in to the astronauts, but one to astronaut Borman really summed it up. The one that struck me the most, he said, "Thank you, Apollo 8. You saved 1968, said Borman, and I think in a way we helped to heal it." Postcards from Mars takes a novel approach of using both solid technical content and a warm personal message using postcard illustration. And it's just that mix of human spirit and appeal to our sense of hope that characterizes so much of Mars Society's outreach efforts. I believe humanity's reach out to space is what in the end will save us all, will lift us all, providing opportunity for all in sectors and metrics we've not yet imagined. I'm grateful to be able to be part of Mars Society's efforts to make that happen. I just want to thank you all.